Assalamu alaikum. This is Dr. Naeem Hayat, and we are here with the chapter 3 for the business statistics. So, last week we discussed about the organizing data, and where we actually discussed about the tables, formation of the tables, where to describe our data, and then we will be going for today, that is actually using graphs to describe the data. So, I will take you a brief reminder for the what we discussed last week. In the last week we discussed about the table. So sometime we have the raw data, and from that raw data we actually need to describe the data, and that description only be possible when we actually describe the data in term of the table. And that table actually start with the data and then actually making a frequency count, that how many item or the data point is actually available to us. So that frequency count is the first step to have the data. Then actually every time a data point is occurring, it is called its frequency. After having the frequency, then actually we measure the frequency, relative frequency, that how many time a data point is actually available from out of the total. So that actually give us the relative frequency, that the data frequency divided by the number of total sample. So it actually give us a relative frequency. That relative frequency that can be described as the percentage as well of the total. So one thing, that frequency, then relative frequency, and then actually percentage of the relative frequency. And that percentage is actually quite easily be done, that multiply by the relative frequency by 100. Another thing that we discuss about the cumulative relative frequency. In the cumulative relative frequency, we actually count the frequency in every column and then actually sum it with the previous one, so that it sum total is equal to the total frequency, and every frequency that occur in one of the column is actually giving the cumulative. So last week we discussed about the one of the example of the car owned by the relative family. We have this 50 sample data points, and then actually we count that how many family have 0 car, how many family have 1 car, 2 car, 3 car, 4 car, or 5 car. We actually make a table of the frequency, then actually make it relative frequency, then the cumulative frequency as well. So this kind of data is called as grouped, non-grouped data, because here possibly we don't form the groups, because the data points are quite easy, 0, 1, 2, 3, 4, quite less. So sometimes it's quite easy to actually describe the data in ungrouped manner or fashion. Sometimes it's quite not easy to describe the data without making the groups. It happens when the data point is quite large, as well as when the data distribution, or you can say the frequency, that vary within each other quite alarmingly or quite well. So that's why the grouping of data or group data analysis or group data frequency distribution is becoming an important thing. So in another example from the slide, which we take, that the 50 data point for the internet user, that how many times they are using the data. Here we see that the data smallest point is 7 and the highest point is 88. So it means there is quite a spread, nearly 81 point of spread from the minimum and the highest value. So if we try to describe the data point independently, so maybe we need 81 data point to describe and then their frequency. It gives a larger activity. So the other option is to group the data, so that we can describe the frequency within these data range in a more appropriate group, 4, 5, 6 groups, instead of having 81 groups. How we can do it? So actually we start making the groups within the data. So for this specific example, the highest value is 88 and the smallest value is 7. So 88 divided by 7. So if we try to actually arrange the things in more appropriately, how many possible? Again, you can say it is 81. 88 minus 7 is equal to 81. So how many data point if we like to make so that all the data points from 7 to 88 can be described easily. So if we actually try to have divide by 5, so actually it may not be divided equally. So this is one option, maybe divided by 5 or maybe divided by 6, because the 6 is the better number for the data point. So in this way, actually, if we divide 88 minus 7, so the class difference, that is 13.5 or maybe 14 if we round off. So it means the group 1 start from the 7 and we add 14. So it means 7 is the low data point, or you can say the class initial point, and then the 20 is the highest data point or data frequency in the group 1. Then the group 1 start with the 21 as the lowest data point, and then the 34, because we are adding 14. So 35 is the third group minimum group initial data point, and then the 48. And for the group 4, that is 49 to 62, 63 to 79, 77 to 90. So again, you can say all the values that we have in the data that range from the 7 to 88. So possibly all the data can be grouped within these data ranges, the minimum range from 7 to 90. So in this way we describe all the data, so it become a grouped data frequency distribution. It means we are making the group, because if you don't make the group, so there are 81 data point, and if you group the data, so it may become with the 6 groups from where you can actually describe the data, and the frequency remain the same, that is 50. So in this way we describe the data within group and non-group form. Okay, similarly we can find the relative frequency of the frequency that described in a data point within the group, and then actually frequency available divided by the total frequency. It gives us a relative frequency, then multiply by 100, it will become the percentage, and when we count the frequency and then add the other frequency in it in the next column, so it becomes cumulative or sum of the frequency, and at the last the cumulative frequency, the last column, and the total frequency or the total data point actually match. So this is the first thing that we discuss about the table or the frequency distribution, or describing the data into the tables form. The other thing that we like to discuss in this chapter as well as in today, that is graphs, that how to describe the data in the graph, or sometimes called a picture form. So there are quantitative variable, qualitative variable, like you can say we discussed when we are discussing the variable. So there are quantitative variable and qualitative variable. So quantitative variable that comes in number, and the qualitative variable that comes in non-number form, description or words. So for quantitative variable, we have the 3 options available that we are going to discuss today, that is histogram, frequency polygon, and OGIF. A qualitative variable, bar chart, pie chart, or contingency table. So in this way actually we describe the data with the help of the graphs. So the first graph that we are going to discuss today, histogram. Histogram, as its name, history, or maybe sometime the frequency or the data that is actually we need to describe with the picture. So that picture actually normally giving you can say on the x-axis and y-axis like a graph, and the horizontal scale is normally quantitative and measure the data value, either class or if it is group, a midpoint or class boundaries, or the vertical scale the frequency. So consecutive bar must touch bar where it begin, where it end. It means they are quite close to each other, next to each other. So we are actually not putting some gap. The gap we can actually put, but in another form, that is in a qualitative. So in a histogram, so we have the data that is mostly quantitative, and we actually on the horizontal axis mostly describe the data point or the midpoint of the data, and then maybe the class boundary. So it's option available. Maybe it's a midpoint taking the central point of the class spread of the class data, and then the class boundary, another option. In the vertical scale, we actually describe the frequencies, and there is a must that the bar must be touching each other, so they must touch. Okay, how to find the, if we actually, it's all about the grouped data. If you don't have the group data, so certainly you don't need to have the midpoint. We just actually describe the range where it start, where it end. So class boundary, where we have the starting point of the class and the ending point, or the maximum and the lowest point of the data point. So the lower point, so we add in the lower point we actually minus 0.05, and in the upper point we add 0.05, and then it becomes a lower and the upper boundary, and then actually divide it by 2 to get the midpoint. So that midpoint is actually the central point within the class boundary, to then we describe it. So how we can do it? Like you can see in the previous example of the 50 internet user. So we have the lower boundary for the class group 1 or class 1, that is 7 to 21. So we minus 0.05, so it becomes 6.5, and in the upper boundary we add 0.5, so then it becomes 20.5. So 6.5 is the lower boundary for the class, and the 20.5 is the highest boundary or upper boundary for the class 1. And then actually 6.5 plus 20.5 divided by 2, it gives us midpoint. The frequency remains same, because there is no continuous number or data in the example. There are all discrete data. So similarly, all the class boundaries, lower and the upper, we actually arrange in a way that we can get the midpoint, and that midpoint actually can be described in the picture form. Okay. So if we go the next slide, so it actually describes the histogram, where we actually describing the internet usage with the, so there are two example or two pictures or two graphs available. That is, one is with the class midpoint, where the calculated midpoint are described, and you see there is no gap between the bars. Another option are actually giving the class boundary, where it's start of the class and the close of the start class is described. So in the first chart, that is the midpoint is given like 13.5, 27.5, 41.5. In the second graph, so we actually describe the data with the data boundaries or the class boundaries. So the first bar start with the 6.5 and end with the 20.5. Then the next is ended with the 34.5. So the horizontal line is actually giving us the time for the online user, and the vertical line are on the y-axis, so it describes the frequency, how many time a user fall within the class 1, class 2, class 3 or class 4. So this is one way of describing the data with the graph, and we call it as a histogram. Histogram mostly used for the quantitative data and to describe the in a picture, in a bar. And there are two options. If it is ungrouped, so certainly we describe them as a whole, but if this is if this is a grouped data, so there are two options. We can actually go for a midpoint presentation, or maybe going for the start, lower or the highest range of the data point in every class. So it is mostly for quantitative data, so that is why it is called histogram. Another option for the representation of the quantitative data is a frequency polygon. So that frequency polygon means that it is based on the frequency, and we actually make a line graph for the data. It means every frequency that we have, so it actually start from one point and the end with some point. And again, there are two are three actually the condition that we need to follow. The horizontal scale is the midpoint of the data value, and the vertical scale is the frequency. So somewhat similar, we can actually use the midpoint, but it is line, it is not bar. That keep in mind that frequency polygon is making a line chart, sometime you can say, but before it is a bar, which is called as a histogram. So it means for the frequency polygon, we actually use the frequency, and the other thing that we use the midpoint on the horizontal line and horizontal scale or horizontal axis, and on the vertical axis we use the frequency of the class. So again, there are two options that sometimes we are using the midpoint for the presenting the data. So a midpoint, we already calculated that it start with the 0.5 minus in the first class and the adding in a higher number. Okay, so on the next slide we actually describe some of the example of the polygon where it start and then actually its midpoint and with the frequency that we can say in a first group there is no frequency, so that's why it start with the 0. In the next point it have frequency of 8, then it have a frequency of 12 in the next. So the midpoint are described on the horizontal line, and on the vertical line the frequencies are described somewhat similar in the histogram, but the major difference that we use the line to describe in the polygon, but a bar in the histogram. So midpoint are used, but in the histogram still midpoint or maybe the class boundaries lower and higher range can be used to describe in the chart form or in the graph form. Another type of the quantitative data chart that is called OGIF. OGIF is actually used to describe the cumulative frequency or the sum total of every class where the data points are there, so that to describe this kind of information we use the OGIF. But keep in mind it is for quantitative data. So it is a cumulative frequency graph and it is a line and that display the cumulative. So before it is frequency we are describing, but here we are describing the cumulative frequency. So how to construct a frequency distribution? Again a table, then actually cumulative frequency of each column, and then actually specify the upper class boundaries on a horizontal line and cumulative frequency. So the difference is on the vertical line in the histogram or in the polygon, so we use the frequency, but here on the vertical line we use the cumulative frequency. So then actually plot the points, actually the cumulative frequency number, and then actually connect the line, and it actually may start from 0. So similarly, when we have the class data for the same example of the internet user, so the cumulative frequency we have, and then actually we make a line, so actually it always move further from the starting point. It means the first point that actually comes on the 8, and then actually 12, and then actually it's move on, and then actually it's end with the highest class with the 50 the cumulative frequency. So in this way actually we describe the data with the line, but it is a cumulative frequency line, not like the other first two charts that we discussed, the histogram and the polygon, where frequency distribution is used. Okay, so here on the we complete the three type of the quantitative data charts. So these quantitative data charts are histogram, polygon, and OGIF. So in histogram, so normally we actually can describe the midpoint on the horizontal line as well as the class boundaries, and on the vertical line we always describe the frequency. Similarly in the OGIFs, in the polygon, so we use the line, and these lines are actually describing the on the vertical line the frequency, and in the horizontal line the midpoints. Then in the OGIFs, so it is actually based on the cumulative frequency, and the midpoint are used on the horizontal line, and on the vertical line the cumulative frequencies are described in terms of the line, and the points are joined with the line. So these are the three charts we used normally to describe the quantitative data. So then the three chart that we use to describe the qualitative data. So qualitative means non-number. But again, number is there, but a category. So actually it is used for the category variable. So bar chart are a distribution of the data for the categorical variable, showing the count or the total of our number that are present, and it's become easy to comparison with the one category to other category. So there is one example that is provided in the slide 27, which said that the car accident, a road accident by the different type of the vehicles, and the people killed, and the total count is 835. And we actually make a bar. So again there is a bar, but the difference between the histogram and the bar, that in a histogram they are close to each other, they are join their boundaries, but here they are, because they are different from each other, so there is always a space. So that space is described as a bar chart, and these are the categorical variables. And then the count, the frequency they have, it is described on the vertical line, like the first accident that is done by the car are having a frequency or the count of 270, the trucks 310, for motorcycle 150, and for others unknown, or you can say which is not category of the vehicle, is described 105. So in this way actually we describe the qualitative data in type of the categories, but they are isolated, they are separated, so that easily understand and defined. So this is bar chart. Another kind of chart or qualitative data that is called as pie chart. So keep in mind it is for qualitative data, which mostly again represented by the categories. So pi is actually a circle. So every circle have a 360 angles. So similarly, if you take the same example, so how to actually divide that, which type, it is actually mostly used for relative frequency. So which type is actually in percentage describing the vehicle that involved in accident. So frequency is the number that in the total divided by the total frequency. Like the first case, cars 270 divided by 835 into 360. So that actually give us a relative area for the circle. So this is 32%, and that 32% out of 3600 angle is 160 angle. So in this way actually we calculate the occupation or the portion of the total cycle or a circle from the frequency that is available, and then actually we use the different color to describe the different category that are present in the data. So normally pie chart is a qualitative data presentation, and that is actually giving us a percentage or the portion that occupy with a specific data categories. Another type of the qualitative data is actually contingency table. So this contingency table is actually again when we have two kind of the categories available, and two types of categories are presented simultaneously in the data. So contingency table actually give us an option to describe the two variable similarly at the same time, and show the individual are distributed among the each variable contingent on the value of other. Maybe you can say two value or two variable that are contingent or can related to each other, or can sometimes we are comparing the variable or category variable. So in the same example, if we know that how many male or female are killed in the accident, so then we have the data, instead of saying 270, then the data is maybe subdivided into two types or their gender, that is male and female, as described in the example. Then in the contingency table, so the marginal distribution is called the group total frequency. Like the total frequency for the data is 835, But in 835, the marginal data distribution on the base of the gender is 655 for male and 180 for male. Another, you can say, if you go for the column side, so for each type of the vehicle, there is also a calculation or the number available, total number available, that is also called a marginal distribution for the vehicle type. So there are two type of the marginal distribution normally in the contingency table, that is for the category of the vehicle or category of the one category, and the other category maybe the gender. So then actually the each cell actually count and combine into the two value, that is they must be total by each type of the vehicle or the types, so that it can actually describe the data. And then in a contingency, so actually we describe the data with one, like you can say maybe different colors are given by type. So 200 is the male and the 70 is the female, so maybe we provide the different color in a bar chart, so that the description can be made possible, or maybe side by side, that how the male and the female are actually killed in kind of the accident that they met, and which type of the vehicle that involved in the accident. So today we discuss about the distribution or describing of the data with the graphs. So we discuss about the three type of the quantitative charts that describe the quantitative data, and we discuss three type of the qualitative charts that describe the qualitative or category of the variable. So we discuss in a quantitative histogram, polygon, and octave. So these are the three type of the quantitative data presentation with the help of the graph. Then we discuss about the three type of the qualitative data chart, that is actually the bar chart, pie chart, and then the contingency table or contingency chart. So these are three types that we discussed today. So that's all for the chapter 3, and we will be meeting again for the chapter 4 to start about the central point measurement of the data. So thank you, that's all.